Picture an 8-foot diameter steel pipe being installed as a culvert. The engineering calculations say it should work perfectly. Soil mechanics formulas predict maybe 5% deflection, well within acceptable limits. The manufacturer's specifications check out. All the theoretical models align, yet within weeks of installation, these brand new pipes are deforming like crushed cans, deflecting over twice the allowable limit. Construction halts. What went wrong? The engineering calculations for flexible pipe behavior rely on well-established formulas that have worked reliably for decades. These equations consider the pipe's stiffness, the soil's support, and the loads from above. For a 96-inch diameter pipe with properly compacted sand backfill, theory predicts deflection should stay under 5%, about 4.8 inches maximum. Even if the backfill performs at half strength, the math says everything should be fine. But immediately upon installation, these pipes showed 6 to 7 inches of deflection with just 3 feet of cover. As fill depth increased to 8 feet, deflections ballooned to 11 to 13.5 inches, approaching 14% deformation. This wasn't gradual degradation over years. This was immediate structural inadequacy in brand new pipes. The issue? Joint behavior. Large diameter spiral rib pipes connect with band joints, metal strips wrapped around adjacent sections. Unlike concrete pipes with interlocking joints that create structural continuity, these bands provide minimal load transfer. Each 24-foot segment deflects independently, creating a domino effect. One section deforms, joint gaps open, adjacent sections lose support, and progressive failure cascades down the line. Once joints separated, sand backfill began leaking through gaps. Each cubic foot of lost sand reduced lateral support, accelerating deflection, which opened larger gaps, which leaked more sand. A vicious cycle. Scale also played a role. What works at 48-inch diameter doesn't necessarily succeed at 96 inches. At this scale, minor variations in geometry, field conditions, and installation can become structurally significant in ways that don't occur at smaller diameters. Multiple factors converged: immediate construction loading, joint leakage removing lateral support, and geometric instability of large, thin-walled cylinders. Each failure mechanism accelerated the others. This illustrates a critical principle. When pushing boundaries of established technology, standard safety factors may not suffice. Design formulas work within their validated range, but can miss failure modes emerging at extreme scales. The resolution involved significant redesign of the backfill approach, a recognition that performance at this scale required fundamentally different considerations than smaller diameter applications. You're about to see narrated field documentation showing what this failure looked like. The following field documentation captures what happens when theoretical predictions diverge dramatically from actual performance. You'll see a 96-inch diameter flexible pipe installation experiencing deflections and structural behavior that contradicts established design calculations. Watch for several key indicators of distress. Notice the excessive vertical deflection, the pipe cross-section deforming from circular to oval far beyond acceptable limits. Observe the joint separation where adjacent pipe sections pull apart, creating visible gaps. These gaps represent both structural discontinuity and pathways for backfill material loss. Pay attention to the progressive nature of the failure. This isn't uniform deflection along the pipe length. Instead, you'll see how distress in one section compounds problems in adjacent sections, creating a cascade effect that the design formulas never anticipated. The conditions you're about to witness occurred shortly after installation under normal construction loading, not from unusual circumstances or extreme events. This represents performance under standard service conditions that should have been well within the pipe's design capacity. These observations raise fundamental questions about applying established design methodologies to installations at the extreme end of the size range, where behavior may deviate significantly from predictions based on smaller diameter experience. The footage provides rare documentation of a failure mode that theoretical models failed to predict.
Okay, we're back at the north end of the double pipe, facing north up the C4 canal. I'm on the west side. You can notice there's a slight upturn of the two pipes. The one closest to me is more drastic, where it appears the top is being crushed while the end isn't. So some deformation is occurring, beginning right here at the soil loading point. That's approximately 7 feet of fill material above the pipes, and that continues on to the south just before the bridge crossing. Okay, we're looking back to the south again at the north end of the double pipe. Again, you can see the 57 stone on either side, sandbags on the interior. You can see the water trickling out of the banks here, all along it. Just about a foot above the existing water line now. Now here we are on the north end of the west pipe. So if you'll notice, you can see the water pouring in here from the shoulder. Notice this little delta of sand that's coming from under the pipe itself. It's actually flowing out. You can see as it's depositing down in here in the creek bottom, canal bottom. And you can also see the effects of the sand migration there as well. It's moving and carrying it downstream. Okay, I'm here in the east pipe on the north end facing south. Off in the distance, there's a spring of water coming in from the west side of this pipe at a pipe joint about a foot above the water line, which corresponds to the groundwater level. And you can see there's deformities in the pipe, beginning with the second run seems to be the most severe. Third run, fourth run, a little more severe. For the fifth run, you can actually make out a collapse. Kind of hard to tell. There's a spring of water. Just beyond the spring of water is the collapse, which is an interesting coincidence. So more than likely sand is filling in the pipe there. And it's deformed for about the next 4 sections beyond that before it straightens out again. Okay, now I'm over in the western pipe, facing south from the north end. And again, you can see severe collapses. 1, 2, 3, 4, beginning at the 4th section, 4, 5, 6, 7, severe collapse, buckling, and failure of the structure itself. Spring of water flowing in from the east side. I can see a sand delta that has formed at that spring flow of water, so there's definitely some piping sand coming in from the joint. I can also see farther down, a couple more pipe sections down, there's another disturbance in the water, probably another boil of sand and water there. Okay, here we are. We're going to walk from north to south in the west pipe. Coming up at the first pipe joint. Appears to be pretty tight. You can actually see here where the neoprene membrane is actually inside of the joint pitch, probably cut. Definitely an offset at the base. This section of pipe's definitely deformed, wider than it is tall. Coming up the second joint here, you can see where it's deformed to the point it's wider on one side and exposing the neoprene liner. Here you can see a little bit of rust from water passing through. 12 to 14 inches deep. That's the second pipe joint. Coming up to the third pipe joint. Slight deformation in the shape of the pipe. Here you can see the neoprene liner. This would be the edge of the liner is actually hanging down inside. Okay, we have a severe deformed pipe here. There's a slight buckle that's beginning at like the 330 and 830 position of the pipes. Here we have a spring of water coming from the fourth pipe joint. And then I'm just now starting to feel sand under my feet. So there was no sand in the pipe up to this point, and I'm starting to feel sand, about an inch or so of sand now, about 4 feet away from the water springing in, about 10 inches of sand. Of course, I forgot my flashlight, so you can see a pretty good spring of water. There's a sand boil right here on the pipe joint itself. Now this pipe section, you can actually here we're going to continue walking out. You can see the banks of the water interfacing with the pipe, the unevenness staggering back and forth. And we're under the bridge now. Pipes are relatively round, except for the very last section of pipe. Appears to be fairly competent. Here there's another boil that's occurring pipe joint. There's sand in the pipe, about 2 inches deep. There's a boil in the very center. About 2 inches of sand here. 2 to 3 inches old. This more here, much deeper, 4 to 5 inches deep. Actually becoming very, very deep now. About 8 inches deep. Here's another boil at this joint. There's a lot of sand in this pipe, probably 8 to 10 inches of sand standing in this pipe now. Very irregular. Pipe joint here, a boil in the base of it. Again, more sand. 4 or 5 inches deep now, maybe 6 at the most. Appears to be fairly continuous. Coming up to the last 2 pipe sections. This one does have a little bit of irregularity to it. Slight deformation here. There's still a lot of sand in the base. Maybe 2 to 3 inches now. Maybe an inch of sand now at the exit. That's it for the east run. I'm at the south exit of this double run pipe. Okay, beginning at the south end of the west run, working my way north. Got about an inch of sand in the bottom of this pipe, and as you can see here, compromised pipe joint. There's sand bubbling up from the joint into the pipe. You can see the fresh sand there. With a lot of iron in this water, algae, iron. 1 or 2 inches of sand, 3 or 4 inches of sand now. These first few sections of pipe appear to be fairly round. Very little deformation to them. Varying depths of sand up and down. Another little small boil, very small though. About 2-inch gap in the pipe section here. You can see the neoprene gasket. Working our way north again. Fairly consistent lines on the either side of the water pipe interface until you get a couple of pipe sections up ahead of me. It becomes irregular there. Got about 4 inches of sand in the bottom of the pipe now under my feet. We're coming up to a really severe buckling. You can see here it is severe. It's actually began to compromise the wall structure. There's a bubble boil occurring just before we get to it. Again, the sand is only a couple inches deep under my feet now. Now I've got no sand under my feet, and it's completely steel, no sand at all. Appears to be numerous pipe joints leaking back there contributing to the sand. Now as I approach this boil, you'll see the overall misshapen pipe itself. That bubbling that you see there is about the center of the boil. Okay, turn on the light here so you can get a little better idea of what's going on. This is a fairly large area of sand. There's probably 3 or 4 wheelbarrow loads of sand here in the bottom. It goes from 0 sand. Okay, here we are. This is the first major boil, 1 of 2. Quite a few wheelbarrow loads of sand here. You can see the boil. About 14 inches deep in sand. About 10 feet long on either side of the joint. You can see the joint there about 2 inches wide. Narrow at the top, wider at the bottom. So it could have just literally blown out. It's about a 10-foot long area of sand in the bottom of the pipe here, 14 inches deep or so. Shot looking back south. Now we're going to be looking north. You can really make out the variation in the sidewalls there. No sand under my feet now, it's fairly clean. Buckling here that's occurred. Integrity of the pipes totally been compromised. You see the shade change, shadows there. Bottom's fairly clean here. There's a little bit of deformation in this pipe section here, but not as severe as the last. Be the 5th pipe section south in the west run, south of the north end of the west run, number 5 pipe section. Now we're coming up to another boil here. This one looks to be a little bit larger actually. It's above the water. about 14 or 15 inches deep. Pretty strong boil here. Start at the pipe joint, 2 inches plus exposed seal. This little sand delta runs out about another 16 or 17 feet. Quite a bit more sand in this one. If we look back, there's about between 20 and 23 feet of sand delta starting at that pipe joint coming north. Okay, it looks like we've got 2 more pipe sections before we're out. A severe drop in the invert of this pipe here. This would be the second pipe joint in from the north end on the west run. I can feel the ballooning of the neoprene pipe ballooning up inside from water pressure on the exterior bottom side of the pipe. Make out the oval shape of the pipe here coming up to the north exit. There's no sand under my feet here. A little bit of sand here at this joint, maybe a couple inches deep, 3 or 4 inches or 3 or 4 feet long, a couple feet on either side of the pipe joint, a couple inches deep, so we got some sand boiling in from here as well. I can feel the pipe at the bottom. And this is going to be the exit point. This is the west pipe run, north end facing north.